The International Space Station is not just a floating lab in space. It's a high-tech marvel facing some of the universe's toughest challenges. How does the ISS avoid collisions with tiny, potentially dangerous space debris? What keeps this massive structure moving and changing direction in the weightlessness of space? And how does it provide astronauts with fresh oxygen when there's no atmosphere up there? Plus, how does it maintain its position and communication with Earth despite the enormous distances and speed? Let's explore the secrets of the ISS and see how this engineering wonder succeeds in the tough environment of space. On March 23, 2012, NASA's Mission Control warned the International Space Station crew about a swarm of micrometeoroids heading their way. With only 6 minutes to react, the astronauts couldn't even change the ISS's direction. So, how does the ISS manage to avoid countless tiny space rocks? And how does such a massive structure, equivalent in weight to 380 cars, move or change direction in space? The ISS, costing around $50 billion to build, is a marvel of modern engineering. It consists of 16 pressurized modules, including living quarters, labs, and an observation deck, all connected by airtight tunnels. Despite its size, the ISS can still be seen from Earth with the naked eye, and its weight is comparable to that of 25 passenger buses. How did the ISS get its start? It began with just 2 modules, one built by the United States and the other by Russia. After the Soviet Union's breakup in 1992, the US and Russia joined forces to create this incredible space station. Russia's Zarya module was launched first, followed by the American Unity module, which joined Zarya in orbit at a speed of 27,000 kilometers per hour. On November 20, 1998, at 6:40 a.m., a historic event took place as the first 2 modules of the International Space Station were joined together 400 kilometers above Earth. This milestone marked the beginning of what would become a remarkable space station. Since that pivotal moment, engineers and scientists from around the world have been tirelessly working to build and connect additional modules, transforming the ISS into a massive and fully operational outpost in space. For the past 24 years, the ISS has continuously hosted astronauts from various countries, providing a unique environment for scientific research and international collaboration. One of the most significant challenges in maintaining this extraordinary space station is ensuring a steady supply of fresh oxygen. Given that the ISS orbits 400 kilometers above the Earth's surface, there is no natural atmosphere or breathable air available. Astronauts living and working on the ISS require about 15,000 liters or 22 kilograms of oxygen each day. With 9 astronauts on board, the ISS needs approximately 200 kilograms of oxygen daily to support their needs. To address this requirement, the ISS has a reserve of extra oxygen stored in tanks for emergencies. If the oxygen system encounters a problem, rockets from Earth can deliver additional supplies within about 6 hours, assuming the launch and delivery go as planned. However, this method is costly. Each cargo rocket trip to the ISS costs around $200 million, and it's not practical to rely on rockets for daily oxygen. Thus, maintaining a steady oxygen supply is both a technical and financial challenge for the ISS. The International Space Station has a smart system that makes its oxygen. Here's how it works. The ISS has a machine that takes water and splits it into hydrogen and oxygen using electricity. On Earth, the gases would naturally separate because they're lighter than water. But in space, where there's no gravity, the machine spins around to create a force that acts like gravity. This spinning pushes the water to the sides and lets the oxygen collect in the middle, where it is then stored. But where does the water come from? The ISS has a clever solution for that, too. It takes the carbon dioxide that astronauts exhale and turns it back into hydrogen. The leftover methane gas is released into space. Keeping the oxygen safe is very important. Even a small leak could be dangerous. Unlike the ocean, where high pressure can crush things, space has no pressure outside the ISS. The station needs to keep its internal pressure stable to avoid any problems. Space is full of debris, including tiny meteoroids and old satellite parts. The ISS orbits Earth at a crazy speed of 27,000 kilometers per hour. At this speed, even small space debris could do serious damage. On March 23, 2012, NASA warned the ISS crew about some debris heading their way. The ISS has protective layers, but these might not be enough if a large meteoroid hits. To avoid collisions, the ISS can be moved out of the way using small thrusters. These thrusters use rocket fuel, which is limited. To handle emergencies efficiently, the ISS has a system that allows it to move without relying too much on rocket fuel. The ISS is huge, about the size of a football field, and it needs to change direction accurately. It uses control moment gyroscopes with spinning flywheels. These flywheels spin very fast, creating momentum that helps steer the ISS. The flywheels get their power from solar panels, which are adjustable to catch sunlight, even though the ISS sees sunrise and sunset 16 times a day. In the past, keeping in touch with Earth was tricky. Radio signals from the ISS had to go through airplanes, which was expensive and unreliable. Now, high Earth orbit satellites handle communication. Signals are picked up by these satellites and relayed to mission control in Houston. This way, astronauts can easily connect with their families with just a slight delay. For 26 years, the ISS has been a place of innovation, striving to become self-sufficient. Scientists are working hard to meet its needs, like chemicals for food and water, spare parts, and crew rotations. Understanding how people adapt to space is crucial for future missions to Mars, where Earth's help won't be as close. The International Space Station is a spectacular engineering achievement, continuously overcoming problems posed by space debris, maintaining its course, and assuring a steady supply of oxygen for its crew. This floating lab not only demonstrates human inventiveness but also serves an important purpose in preparing for future space exploration. What aspect of the ISS's unbelievable technology surprised you the most? Do you think these advancements will pave the way for even more ambitious missions in the future? Let us know your thoughts in the comments. That's all for this video. Thanks for watching and stay tuned for more content like this.